Hello, fellow classmates. It's me once again, here providing you a presentation over providing heat and light from the center of the universe. My name is Curtis Lewis, and this is for my Physics 2 class. Providing heat from the center of the universe would be none other than the sun. This is the sun as we know it, instead of the animated art version. The sun provides heat, light, and everything to us as we need it for everyday life. Here's some quick facts about the sun. First off, did you know that the sun is 93 million miles away? It has a diameter of 1,400,000 kilometers. It's made of gases. It's not a solid. Mostly hydrogen and helium make up the sun. At the core, the temperature is 27 million Fahrenheit, and at its surface, it drops down to a mere 11,000 degrees Fahrenheit. We're going to cover the sun's benefits, which are greatly underappreciated in that it provides heat and light to us. Don't seem like a lot, but as I cover it, you will understand how great of an accomplishment it is to have those benefits from the sun. Before diving into how the sun does it, we're going to look at the sun's layers. In the center here, you can see the core, where all the processes begin to take place before moving outwards. Then next you'll see the piece surrounding the core, which is known as the radiative zone, where from the core it begins the next step to move on forward to the next zone, known as the convective zone here, the red zone. And from the convective zone, the main thing we need to look at here is the photosphere. You'll see the word over here, which is pretty much this whole area. The gases around, it's the atmosphere of the sun. While it's not everything you see here, it is the greatest part of it right through here. You will also see a flare over here, which is heat and light being emitted, along with a prominence over here. You also see solar wind, which also provides us with heating up our surface, our oceans, and everything when they're sent out. How does the sun produce it? Well, that's a great question, and until this project, you don't think much about it. But it starts out in the core, as I said in the previous slide, and goes through a number of chemical reactions known as nuclear fusion. It starts out as a hydrogen atom and is then broken by the great heat at the center of the earth, or center of the sun, becoming hydrogen nuclei, which are then taken and formed into helium 3s. Them helium 3s are then becoming helium 4s. That's known as hydrogen to helium fusion. That fusion is 85% of the energy we get from the sun. You also have another 15%, which is made up of 3 reactions that also lead to the production of helium 4. So from the core to the radiative zone, we see the helium 4 become photons that begin a long repeating cycle. The photons travel 1/1,000,000th of a meter each time before being absorbed by a gas molecule. And once absorbed by that gas molecule, it is heated and re-emitted as a photon. After being re-emitted as a photon, it repeats this cycle over and over and over again. It actually, by the time it's said and done and leaving the radiative zone to go to the convective zone, has been absorbed and re-emitted approximately 10 to the 25th power times. which leads us then to the convective zone, which was the outer layer surrounding the radiative zone that surrounds the core. The convective zone is named the convective zone due to convection currents, which include rising hot gas and then the falling movement of cool gas. And the photons are pushed up and down by those movements of the gas in the convective zone. Which brings us to the final layer that I said was so important, the surface, known as the photosphere, which is the atmosphere of this gas ball, huge star known as the sun. Excuse me. And after 100,000 to 200,000 years of traveling from the core, it finally reaches this photosphere. And at the photosphere is when we see, like the flares in the sun's layers picture, emitted out into space. At that point, it begins to travel through space into Earth. The photons travel as energy, which is transferred as light, and they come in contact with every planet in the solar system. While doing this, it will hit each planet. When it hits that planet, it will lose some energy, giving off some to that planet, before moving on to the next planet, where it will once again take energy and bounce off to the next planet. And this repeats as it flies through the solar system before there is no energy left by the time it reaches the planet that was once known as Pluto. So all in all, we want to send a big thanks to Mr. Sun. From the plants, the animals, the lands, the oceans, and all our inhabitants. We want to say thank you because without our light and our heat and how great of a contribution it really is to us, we would not be able to live. Our day-to-day lives are affected as the sun gives our plants a chance to thrive, live, feed themselves. Excuse me once again. The plants are then being fed on by the animals. The animals are then fed on by us, fed on by each other, which allows us all to grow and thrive in life. The heat provides warmth for all of us to be able to live in this, because we cannot live in sub-zero degree temperatures. The lands, the oceans are all affected from the soil being able to grow, which goes into the plants, and the oceans, it moves the tides and everything from that sort. And then last but not least, I want to thank my references for helping me along the way, helping me grab a great understanding of these physics. I also want to throw a shout out inside the articles to Einstein, whose E equals mc squared was very relative, no pun intended, to help me move along and realize just how great of a deal the sun was to our Earth.